Okay, the lesson for today is section 7.7 of your textbook, to find the areas of circles, sectors, and segments of circles. So you can use your highlighter to underline the important parts or highlight the important parts. The area of circles, the area of sectors, and the area of segments of circles. And here you have your North Carolina Standard Course of Study objective. Label that slide number 1. And we'll move to the next slide, and you can label this slide number 2. This slide gives you your first theorem, which is for the area of a circle. You're already familiar with the area of a circle, so I'm just going to go through this briefly. The area is equal to pi times r squared, where r is your radius. But let's go through a real-world example. How much more pizza is in a 12-inch diameter pizza, and that's important, than in a 10-inch pizza? So in your warm-up, you already saw the relationship between the diameter and the radius. So if the diameter is 12 inches, what is your radius for that pizza? And if you look over here, you see it is 6, because 12 divided by 2 is 6. And the radius for your 10-inch pizza is 10 divided by 2, which is 5. So you have to think of a plan. How will I find the difference? Well, the plan is to find the area of each pizza, and then after you find the area of each pizza, you subtract, and that tells you your difference. So here we see the area of the small pizza is pi r squared, where r is 5. You leave your answer in terms of pi, and you get 25 pi. Here you see that the area of the medium pizza is pi times 6 squared, because r is 6 in your medium pizza. So you have 36 pi. Now you have 36 pi minus 25 pi, because you find the difference, which means to subtract. And you get 11 pi. So the difference is there's about 35 square inches more pizza in the medium pizza. So now, do you understand that? If you don't understand, review the slide, and we're going to move on to slide number 3 now. This is a check understanding so that you can actually work a problem out and see if you know how to do this. How much more pizza is in a 14-inch diameter pizza than in a 12-inch pizza? So you're going to take some time now, and you're going to work this out by yourself or with your partner, and label this slide, slide number 3. Okay. So if you need to turn off if you need to stop right now and pause, go ahead and pause so you can do your problem, and then we'll review the answer. Okay. So here it is, right here. You have the area is equal to pi r squared. Well, in one pizza, you have a 7-inch radius. So which pizza do you think that came from, the 12-inch or the 14-inch? If you said 14-inch, you're right, because you had to take 14 and divide by 2, and that's how you get your radius. So you find the area of that pizza, and then you find the area of your other pizza, and you subtract, and you find the difference. So the difference is approximately 13 pi square inches of pizza. If you want a number for that, then you just multiply 13 times pi on your calculator. Okay, and that slide is not in your presentation. That's the same slide you just worked on, so I didn't put the answer slide. Now we're moving on to slide number 4. On your slide number 4, you have some missing pieces. So when I underline, that's where you will fill in the blanks for your missing pieces. This is talking about a sector of a circle, and you can see it looks like a piece of pizza. This whole region right here is called the sector of the circle. So this is a region bounded by an arc of the circle and the 2 radii to the arc's endpoints. So they say radii because this is a radii, it's a radius, and this is a radius. But when you use the plural of radius, it is radii, so that's why they use that language. And so you would fill in the word 2. Now how do you name a sector? You name a sector using one arc endpoint, the center of the circle, and the other arc endpoint. So let's see what you need to fill in here. One arc endpoint, and then also the center. And then the other arc endpoint. So you're gonna have X, O, Y when you name this. The slice of pizza below is sector X, O, Y. Okay, of circle O, because remember the center of the circle names the circle. That's slide number 4. Let's move on to the next slide. This is your slide number 5, and here's the theorem that goes with the area of the sector of the circle. We already found the length of a sector, and when we found the length of this region right here, which is actually called arc length, we had 2 pi r here because that's circumference, and circumference deals with the distance around. But I mentioned to you that we would also be able to find the area within, and since we're looking for the area now, we're going to use pi r squared in the place where we used to use 2 pi r. So that's the formula here. The area of a sector of a circle is the product of the ratio measure of the arc, whatever this is, divided by 360. Remember, how can we use 360? Because there are 360 degrees in a circle, good. Times pi r squared, because the area of a circle is pi r squared. So now look at this example. You want to find the area of sector ZOM. So you want to find the area right here. And the good news is they give you the 72 degrees. And they want you to leave your answer in terms of pi, so you don't need to multiply by pi, you just need to bring it down. So you have the measure of arc ZM divided by 360 degrees. So that's 72 degrees divided by 360 times pi times r squared. They also give us r here, which is your radius. And when you multiply that, you get 80 pi. And since area is in square units, you have 80 pi square centimeters, or centimeters squared. That's your slide number 5. If you need to review the slide, you may, or you can look on your paper when you're doing the next problem. So check understanding 2, I would like for you to do on your paper. I left you can label that slide number 7. Actually, slide number 6 looks just like this, but you're going to do your work in slide number 7. A circle has a diameter of 20 centimeters. What is the area of a sector bounded by the 208-degree major arc? Round your answer to the nearest tenth. So here they do want you to multiply by pi. Go ahead, draw your circle, draw your diameter, think about what that means as far as the radius goes, and they gave you the 208-degree major arc that they want you to find the area of. So work that out. If you need to pause at this point, go ahead and pause. Okay, so you should have done this check understanding now. This is check understanding 2, which is slide number 6, and you've shown your work in slide number 7. So let me go over here and see how you did. We have a circle with a diameter of 20 centimeters. So if your diameter is 20 centimeters, then we know our radius must be 10 centimeters. We have a 208-degree major arc, and we want to find the area of the sector that's bounded by that arc. So we have 208 divided by 360 because of the degrees in a circle, times pi r squared, but r is 10. Okay. So we know when we have area, our area is in square units. So now what we're going to do is 208, 10 times 10 is 100. You have your square units, and you can put your pi right here for now. We multiply out, and all we really need to do is add those two zeros because we multiply by 100. Since we want to round our number to the nearest tenth, we actually put in our calculator now 20,800 pi. To get to pi, you hit second, and then you hit the up symbol, you hit the caret symbol, and that will take you to pi. So put in 20,800, don't put any commas because the calculator will read that differently, and then put pi. The calculator knows that that means you're going to multiply by pi. Now hit enter and divide by 360. I'm going to do the same thing, 20,800 pi, enter, and then I'm going to divide by 360. Now I'm going to round my answer to the nearest tenth, and I get 181.5 centimeters squared. You can also say 181.5 square centimeters. And that's what you should have for check understanding 2. Now we're going to move to slide number 8, which is the last one you really need to learn. And let me go ahead and erase this. This is on page 397 of your textbook, if that helps you. Here's the solution. Okay. A part of a circle bounded by an arc and the segment joining its endpoint is a segment of the circle. So here we have the segment of the circle. If you want to find the area of the segment for a minor arc, draw radii to form a sector. Okay, the area of the segment equals the area of the sector, but this is a sector, minus the area of the triangle. Because if you take this whole piece and you take out the triangle, then that's what you have left. So I'm going to show you an example on this. Okay, let's look at example number 3. Example number 3 is your slide number 9. You want to find the area of the shaded segment. And you want to round your area to the nearest tenth. So you have to remember how to find the area of a triangle. And what is the formula for the area of a triangle? Okay, area is equal to 1/2 base times height. Well, we're lucky here because our radii make up our base and our height. So we know that we're going to use 1/2 10 times 10 for the area of our triangle. And that's where this comes from. 1/2 10 times 10 is the area of your triangle. Half of 100 is 50. For the circle, we know our area is pi r squared. So we're going to put that here so that we can find the measure of this segment, the area of this segment. The segment is the entire piece. So we're going to use 90 degrees because we have our right angle, divided by 360 degrees, times pi times your radius squared. That's the area of your circle. You work it all out and you get 25 pi. Excuse me, that's the area of your sector. So now you're going to take this piece out because you want to get rid of this triangle. You have to subtract the triangle's area from the area of your sector. So find the area of your triangle. You've got the area of your sector. You use subtraction, put 25 pi in your calculator, minus 50, and you get this number right here. And you have to round it to the nearest tenth. Since 3 is less than 5, you keep your 5 as is. And so the area of the piece that you want right here, which is called a segment, is 28.5 inches squared, or 28.5 square inches. Now you have one more slide on your paper that requires you to do work, and that's slide number 10. So what I would like for you to do is work out slide number 10, check understanding number 3. When you finish, let me see your answer, and if your answer is good, you can move on to your work. So let's go. You can pause, and then you can turn it back on and see what the solution is. So now you have a circle that has a radius of 12 centimeters. Find the area of the smaller segment of the circle determined by a 60-degree arc. Round your answer to the nearest tenth. You would definitely need to draw a circle here so you can get a good picture of what they're asking for. So we have a circle. We have a radius of 12 centimeters. And in addition to that, we have a 60-degree arc. So now we have to draw our triangle. We have our radii. But in a triangle, you need the base times the height. We don't have that. We have the sides, but we don't have the base, which is right here, and we don't have the height, which is right here. But we do know We do know that if the arc length is 60 degrees, or the arc measure right here, the length, then that is also the central angle measure. We did that in section 7.6. But you also know that when you take and you split this to make that a right angle, you drop an altitude, you just cut that angle in half. So what's half of 60? So you have a 30, 60, 90 triangle. So you have to go back to your 30, 60, 90 triangle. Your hypotenuse, I'll draw you a figure right here just to help you remember. Across from your short leg is your 30-degree angle, which is S. Your hypotenuse is 2 times S. And your long leg, which is across from your 60-degree angle, is S square root 3. So we see that what we have here is the hypotenuse. So we're going to set that equal to 12 so we can find the short leg. Because the short leg is going to give us half of our base. So we have 2S equals 12. And we find out when we solve for S that S is equal to 6. So our short leg is 6. And then we put 6 on the other half. So we have our base now. Our base is 12. But we want our long leg also, which is our height. Our long leg is just S times the square root of 3. Well, S is 6, so that's 6 square root 3. So now we have our height. So now we can get the work done, because now we can find the area of this entire piece minus the area of the triangle, so we can get that little section right there. So we have the area of 60 degrees divided by 360 degrees times pi times the radius, which is 12 squared, okay? And from that, you can go ahead and set it like this if you want. You're going to have the area of your triangle, which is 1/2 the base, which is 12, times the height, which is 6 square root 3 centimeters. So you go ahead and work it out over here and see what you get. So we know 60 divided by 360 is really 1/6. Times 12, which is 144. And you also know that half of 12 is just 6. And we know that 6 times 6 is 36. Square root 3. Okay, so now we can work it out from here. Take your calculator, do what you need to do. Remember, our answer has to be rounded to the nearest tenth, so you do want to put pi in your calculator. So you're going to put 144 pi divided by 6. So 144 pi, hit enter, then divide by 6. And you have approximately 75.39. If you round that, it's really 80, so let's round it to the nearest 10. 75 point, if you rounded that, you would have to go up to 76. So let's just round that up to 75.4. Minus, now put in 36 square root 3. And that's approximately 62.4 when you round it. And then subtract. And you get to the nearest tenth, 13.0. And so the answer is, round your answer to the nearest tenth, is 13.0 centimeters squared. So if you did not understand, feel free to ask me a question on that one, or anything that you didn't get. But I'd rather you review the slide, make sure you feel good about it, and then you can work on your assignment.